Okay, so this is one more example at this formula that I have given you, this g of x equals, g prime of x, excuse me, equals 1 over f prime of g of x. And in this case, we actually have a g of x. It's negative 1/2, negative 1/2. So we're actually finding this specifically at g and 1/2. So the first thing I need is what is g to the negative 1/2? Well, recall that g to the negative 1/2, sorry, it's not wanting to write, is the same as f to the negative 1 of the negative 1/2. And remember that in in terms of the actual original function, this is the y, which equals the x. So if f of x is x to the third over x squared plus 1, I'm looking to find out what x is when y is negative 1/2. And you can go ahead and do some factoring here, but what you will find is that when x is equal to negative 1, this works, because negative 1 would go in the numerator, but you'd have 1 plus 1 in the denominator to get 1/2. So x is equal to negative 1. I'll let you verify that on your own if you want to with various algebraic means, which will involve factoring and some nasty factoring at that. So that means g of negative 1/2, if you flip the x and the y, is equal to negative 1. So going back on that definition of an inverse. All right, so now I know that g to the negative 1/2 is negative 1. So 1 over f prime at negative 1. So I'm going to give myself some room because I need to find f prime. So if f is x to the third over x squared plus 1, f prime is 3x squared times x squared plus 1. Oop, not equals, minus. And then it's going to be x to the third times 2x, all over x squared plus 1 squared. So now f prime of negative 1 is going to be 3, and negative 1 squared is 1, and 1 plus 1 is 2. And then that negative 1 cubed is going to be negative 1, so I'm going to call it plus 1. And then 2 times negative 1 is negative 2. And then I have 1 plus 1. If I put the negative 1 in, it'll become 1. 1 plus 1 is 2. 2 squared is 4. So I'm ending up with 6 minus 2 is 4 over 4 is 1. So then my final answer here, if I take 1 over f prime at negative 1, is going to be 1 over 1, which is just 1.